Hi, in this video, I'm going to demonstrate how I built a graphical model from scratch. I will show you how I collected my raw data, how I used Desmos to represent it graphically and find a best fit line or curve, and how I laid out my model using the whiteboard template. First, take a look at my original observations that led to my guiding question.
Let's have a three-way tie on the dollar. Who do you want to say hello to?
I just want to say happy birthday to my friend Steven and just my parents, my grandparents, all my friends that I'm here with.
Hi, everybody. How you doing? Looking for that dollar. We're on a three-way tie on the dollar. 85, 85, 85, 85, 30. 70 is what you're looking for. It's right up at the top. 70's right up at the top. Good luck. There's your 70. A three-way tie on the dollar would be amazing. There's the 70. This just might happen. This just might happen. 70, tie, three-way tie, three-way tie, three-way tie, three-way tie. Yes! 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 Come on over here, all you guys. Come over here.
This observation of the big wheel led me to the guiding question: how do the number of beeps depend on the amount of time the wheel has been spinning? Here is the data that I collected to model the wheel. I created a column for clock reading, which is measured in the seconds since the first beep, and the beep count, or the number of beeps, as a variable that depended on the clock reading. I used the timestamp on the video to note when each beep happened. This was definitely a source of uncertainty in my experiment because it was pretty hard to pause at exactly each beep, but I was also able to use the visual of clicking over to the next section to get as close as I could. Finally, I repeated my observation for both spins so that I could compare them later. Raw data is uncertain, so the best way to look for patterns is to represent it graphically. Since both of my variables are numerical measurements, I need to use a scatter plot, sometimes called an XY plot. I'll use the online graphing calculator Desmos to do that. First, I'll log in so that my work will be saved. Then I can launch the calculator. Next, I'll paste in my data. Let's start with spin number 1. You can also type your data directly into Desmos by choosing this plus sign and clicking the table option if that's easier for you. Desmos will default to naming the columns X1 and Y1, but I'll go ahead and change them to represent my actual question. My horizontal axis isn't X, it's clock reading, so I'll use T for time. And my vertical axis isn't Y, it's beeps, so I'll use B for beeps. I can also add labels to my graph axes here. If I click on the wrench, I'll add a label for the x-axis, which is clock reading. And my y-axis, which is the beep count, the number of beeps. This looks pretty nice, and I can definitely make some claims based on what I see. I can tell that the beep count is increasing as the clock reading increases. But I think I can still do better. Since I'm trying to find a pattern, I will add a best fit line or curve to this data. All I care about right now is whether the shape is a straight line, a curve, or something else. Maybe it's a combination of the two. Let's start with the simplest option, which is a straight line. I know that in general, a straight line is represented mathematically as y equals a constant times x plus another constant. I'll type that in here. Notice that I'm using C1 and C2 as the two constants. If I now choose the All Sliders option, I can play around with my line to see if I can get it to match the data. It looks pretty good for this first part of the data, but there is clearly a curve going on as we get closer to the end. So let's adjust the mathematical representation to include an x squared term. I'll change this x to an x squared. I'll bump my x term down to the second term, and I need to add another constant, which represents the y-intercept of this graph. Now I have 3 sliders to adjust. There, I think that looks pretty good. One thing to note about this is that even though the best fit line is a complete curve that curves down at the end here, I know that doesn't mean that the wheel is going to start beeping again all of a sudden after a certain amount of time and that the beep count is going to go down. I would have to just say that this best fit line is only valid until the time that the wheel stops. Now that I've collected my data and done some analysis, I'm ready to set up my whiteboard presentation of the wheel spin model. Before I put my graph on my whiteboard presentation, I went ahead and added some labels. The second spin data with best fit curve, and I'm going to go ahead and export this so I can put it on my whiteboard.